Welcome! In this video, we're diving into the world of regular expressions, or regex, and exploring how they differ across various programming languages. We will uncover syntax variations, feature differences, and implementation quirks that you should be aware of when working with regular expressions in different environments. Let's start by examining the basic syntax variations between Python and JavaScript. On the left, we have Python code. Notice how we import the re module to work with regular expressions. The pattern is defined as a raw string, denoted by the R prefix, followed by the regular expression for one or more digits, which is \d+. We then search for this pattern within the text age 25 using re.search. On the right, in JavaScript, we define the same pattern using forward slashes. The regular expression is /d+/. Then we use the match method to find the pattern in the text age 25. These are just a couple of examples of how the syntax can vary slightly between languages. Now let's focus on delimiter differences in regular expressions. Some languages use forward slashes to enclose regular expression patterns, while others rely on string literals. On the left, we have languages like JavaScript, PHP, and Perl, which typically use forward slashes as delimiters. The pattern is enclosed within forward slashes, followed by optional flags. On the right, we see languages like Python, Java, and C#, which use string literals to define regular expression patterns. In Python, we often use raw strings, prefixed with R, to avoid excessive escaping. Java and C# use standard string literals, which may require double escaping for certain characters. Flags modify the behavior of regular expressions. Let's look at some common flags and how they are used across different languages. First, we have the I flag, which stands for case-insensitive matching. When this flag is applied, the regular expression will ignore case differences between the pattern and the text. The code example shows how the I flag is used, /pattern/I. Next, we have the G flag or global flag. This flag tells the regular expression engine to find all occurrences of the pattern, rather than stopping after the first match. The code example shows the G flag usage, /pattern/G. Lastly, the M flag or multiline flag changes the behavior of the caret and $sign meta characters. When the M flag is set, the caret and $sign match the start and end of each line, respectively, rather than the start and end of the entire string. Example code /pattern/M. Escape characters are used to give special meaning to characters within a regular expression. However, how these escape characters are handled can vary between languages. On the left, in Python, we can use raw strings to avoid double escaping. A raw string is denoted by the R prefix before the string literal. This is the recommended approach, as it simplifies the pattern and reduces the risk of errors. Without raw strings, you would need to double escape backslashes. On the right, we have Java, which always requires double escaping for backslashes in string literals. This is because backslash is itself an escape character in Java strings. To match a literal backslash, you need to use two backslashes. The note in this case is that Java always requires double backslashes. Character classes are sets of characters that can match a single character in the input string. However, the definition of these classes can differ between languages. The table displays the pattern for digits, which is \d, and it is shown as 0 to 9. For word characters, it is defined as \w. In Python and JavaScript, it matches letters, digits, and underscores. In Java, it matches Unicode letters. And finally, for whitespace, it is defined as \s. In Python and JavaScript, it matches standard whitespace characters, whereas in Java it matches Unicode spaces. Some languages offer unique features in their regular expression engines that are not available in others. On the left, we have Python's named groups. Python allows you to assign names to capture groups using the syntax question ~p angle brackets name angle brackets. This makes it easier to extract specific parts of the matched text by referring to them by name, rather than by number. On the right, we have Perl, which is known for its advanced regular expression capabilities. Perl supports recursive patterns, which allow you to match nested structures, as well as possessive quantifiers, which prevent backtracking and can improve performance. So these advanced pattern matching capabilities are a hallmark of Perl's regular expression engine. To summarize our discussion, let's review some best practices for working with regular expressions across different languages. For testing and documentation, always test your patterns across target languages to ensure they behave as expected. Document any language-specific behavior to avoid confusion, and use online regular expression testers for validation and debugging. For portability tips, use raw strings when available to simplify patterns and reduce the risk of errors. Avoid language-specific extensions to ensure your patterns are as portable as possible, and keep your patterns simple and readable to make them easier to understand and maintain. By following these best practices, you can improve the reliability and portability of your regular expressions across different programming languages. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.